One thing you'll notice as you continue learning more and more in math is there are foundational skills, right? We start with adding and subtracting integers, which are counting numbers, including 0. And then you do multiplication and division, order of operations, right? And then we move to those same tools, but do it with fractions or do it with decimals. And so many of the skills that we've already learned, we're using here. The difference is that it's with fractions. So I think it's really helpful to take a minute and kind of think about what we're building on so it doesn't feel like every single problem type we're learning is completely brand new. So exponents are done the same way with fractions, right? We need to follow the rules of fractions to do it, but exponents still mean the same thing. Order of operations, you still use order of operations. You just use the tools and rules for fractions when your numbers are fractions, okay? So remember, exponents are repeated multiplications. I'll just make a little note about that. So repeated multiplication. It's just one of those new calculation tools that we have that make things more efficient, right? So instead of having to multiply things over and over and over again, you just set up your exponent and do your calculation. Much more efficient, far fewer chances of making a mistake, because anytime you're repeating something over and over again, it's easy to miscopy, right? Misenter, any number of things. All right, so as we've talked about exponents before, the first thing that we have to do is identify the base, because that tells us the value that the exponent is applied to. The question of whether something is included in parentheses or not is critical still. So looking at the first one, we have parentheses around -2/3 squared. So the negative is part of the base. So that means that -2/3, right, is what the exponent is being applied to. The exponent is 2. Now we need to expand. I'm going to go ahead and use parentheses to indicate multiplication. It's just a preference of mine when I'm using fractions. Let's copy that correctly. I don't want to be making stuff up here, if I can avoid it. Okay, and now it's a -2/3 times a -2/3, which means my answer has to be positive. And then I have 2 times 2 is 4 over 3 times 3 is 9. So I want to specifically point out the way that I talked through that multiplication. Notice that I paid attention to the signs first. So I said a negative times a negative is a positive. I now know the sign for my answer. It's positive. So then I go ahead and do the multiplication, right? 2 times 2 is 4. 3 times 3 is 9. I find that focusing on the signs first and then moving to your multiplication, same thing with division, is really, really helpful. So I encourage you to try that if you find that you make mistakes on figuring out the signs for your answers. All right, so for the next one, the difference, well, obviously 2/3 is different, right, than 1/2. The exponent is also different, but looking at the base and the placement of the negative, the difference is that in the first one, the negative is in parentheses, and on the second one, it's not. So that means that the base of your fraction, or the base of your exponent is a fraction, which is 1/2. Your exponent is 3. So that negative is on the outside of parentheses, which means you don't have to write this, but I just want to illustrate another way that you can look at this. It helps with the expansion, right? It's that -1 in front of something. So that means when I expand, I need to show the -1 times, and now I have 3 of these, that I'm multiplying because of that fraction, that exponent, of 3. I'm really wanting to use the word fraction for some reason. Anyway, bear with me. I'm going to blame it again. Not enough coffee or too much. I won't test it. How about that? All right. So here I have -1 times 1/2 times 1/2 times 1/2. This process, or the way that I'm going to write this first, you don't have to include, but I do encourage you to do it if you find that the bigger your exponents are, the easier it is to make mistakes, right? And that you keep making little calculation errors. Here's what you can do to help with that. So we have -1 times, this is the same as 1 cubed over 2 cubed, right? Because I have 3 1s up here and 3 2s down here that I'm multiplying. Now I can say, all right, well, that's -1 times 1 cubed. Anytime your base is 1, it simplifies to 1. And then 2 cubed is 8. So now your final answer is -1/8. So this right here can be really helpful for visualizing what's actually happening. Okay, and some of you may feel more comfortable with like 2 cubed. You might know what that is. So seeing it that way can help you simplify correctly. So I always try to include a couple of different ways to think about things, especially if it's something that people tend to make mistakes on as they're learning. All right, so I want you to go ahead and try the third one here. So pause the video and try it. Go ahead and turn it on and see how I go through it. All right, so step 1 is to identify the base. The reason that I have this written out in its 4 specific steps is because these are the steps I want you to use every single time you do an exponent. Don't skip over any of them. Okay, pause for a second, think, what is the base? Pause for a second, think, what is the exponent? If we rush, it's really easy, especially with negatives, to do them incorrectly. So I've broken this apart very specifically, again, to train our brain, to train the pathways in our brain so that we're doing the same thing every single time. And eventually it will get to the point where you don't have to think about every individual step. That brings me to something that I like to compare learning to, and helps me identify whether I have truly learned something or not. So I'm guessing most of you drive. If you don't, you have something to look forward to. But for those of us who do drive, think about the first time or the first few times you were behind the wheel. I remember that using the gas pedal, using the brake pedal, using the turn signal, everything was an individual step that I had to think about. Now, many years later, which I'm not going to admit how many years later, because that makes me old and I want to hide behind youth. But now I don't have to think about everything. It just happens. It's all coordinated. That means that I have fully learned it. So if you're still looking at exponents and having to think through each of these steps individually, it means you have not learned it as much as you need. Okay, so a great way to measure your understanding of something. All right, so my base, I have parentheses. There's a negative inside of it, so that negative is included in the base. So I have -3/4. This time I have an exponent of 4, which means I am multiplying 4 of these things together. Now it says to expand. So I'm going to go back over here and I'm going to do the same thing that I did above where there was a negative on the outside. I'm going to write -1 times, and then I just rewrite everything to the right. Okay, that reminds me that when I expand, I have to start with that -1. and then I multiply. Now I have 4 of those negative 3/4 that I'm multiplying. So negative 3/4 times negative 3/4, negative 3/4 times negative 3/4. I also want to point out that we are always following order of operations. So you cannot apply the -1 to the negative 3/4. You have to do your exponents first because that's what GEMDAS says, right? So make sure that anytime you're doing math, you're thinking in terms of that GEMDAS framework because you always use GEMDAS. Going back to the car analogy, PEMDAS or GEMDAS, that is the rule of the road. Every time you drive, you have to follow the same rules. Otherwise, there are going to be a lot of accidents, right? With math, you have to follow GEMDAS, the rules of math, every single time. If you don't, you will have a lot of accidents, right? You'll get a lot of answers wrong. I have not written GEMDAS down, but if you find yourself forgetting to do GEMDAS, always write it so you have it to refer to. If you don't know why I have it written the way that I do, go back and watch the Introduction to Order of Operations video, and I'll tell you why I've used a G and why things are written horizontally. I'll be talking about it a little bit as we start applying more order of operations to problems with fractions, but it's good to go back and review just the basics of order of operations with integers so you don't have to be worrying about the rules of fractions as you review that. All right, so we're simplifying with fractions. We've done this with integers before. Now we're doing it with fractions, and that just tells me that I need to be thinking about the tools that I have for fractions, right? Remember that exponents are repeated multiplication. So that means that when I am multiplying these fractions, I'm following the rules for multiplication of fractions. You may be like, well, yeah, that's obvious. And maybe it is. But it's really easy to lose sight of that as things start building, right? It's that tying what we're doing now to what we've done before so that it doesn't feel new. When I was learning math, I felt like everything was its own tool that I had to remember. It was so overwhelming. It was like, oh, another thing, right? But it's not that. We're actually starting with foundations and we're building 1 or 2 things onto the foundation. So it's that 1 or 2 new thing or things that we have to be paying attention to as long as we're already comfortable with the foundation. And that's where practice comes in. All right, so here we are simplifying. We don't have the table, but I'm still going to take us through that same process. So we identify what the base is, which is 3/4, right? We identify the exponent, which is 2. So I'm going to go ahead and expand to 3/4 times 3/4. And then I multiply and I get 9/16. And that is your final answer. Because it's multiplication, keep in mind that the first step that we've talked about for multiplication is to cross cancel. This is a different context, but it's still multiplication. So when you look at 3/4 times 3/4, there's nothing to reduce. So that's why I didn't do cross canceling. But if there was something I could have reduced, I would have gone ahead and done that. All right, so for B, I need to identify the base. Well, this time there's a negative inside of the parentheses. So my base is -2/3. My exponent is 2. So I am multiplying 2 -2/3 together. I think I find that if it's a negative fraction, I use parentheses. If it's positive, I use the dot to show multiplication. Either is absolutely fine. It's just whatever works for you. Apparently, this is a strategy that I've come up with over the years. You would think I would know all of the strategies I use. I guess I do, but sometimes I verbalize it when I kind of realize that, oh, that is a choice that I've started making. So anyway, you may do it a little differently. That is totally fine. Once again, it's whatever works for you. All right, so I need to multiply this by another fraction. This is another one where I am multiplying two negatives together. So I know that my answer has to be positive. So I get 2 times 2, which is 4, over 3 times 3, which is 9. And again, I already identified that that had to be positive. So I, multiplied the numerator, multiplied the denominator, and then left it positive because I'd already identified that for my final answer. All right, so for C and D, I want you to go ahead and pause the video, go ahead and try them, and then turn it back on and compare it to what I did. All right, so the base for C is -1/5. Now I have 3 of those that I'm multiplying together. So I have, there are my parentheses again, 1/5 times -1/5. Well, in this one, I'm going to still go ahead and identify the sign of my answer. Notice that a negative times a negative is a positive, times another negative is a negative. So my answer is going to be negative. Now I go ahead and multiply across, and I get 1 times 1 times 1 is 1. 5 times 5 is 25, times 5 is 125. All right, so now looking at D, I need to identify my base again. So my base is -2/5. But notice here, it's that negative on the outside. So I'm going to show that part. Right? The negative on the outside is the same as multiplying by -1. So when I expand, I have to include that -1, right? So I have -1 times my base, which is -2/5, and I am multiplying 3 of those together. All right, so my sign here, right? Negative times negative is positive times another negative. So my answer is going to end up negative. But I also have this -1, right? So it's -1 times, I know that once I combine those -2/5, the inside is also going to be negative. Now I have 2 times 2 is 4, times 2 is 8, so that gives me 8. 5 times 5 is 25, times 5 is 125. And now I have a -1 times a -8 125ths. So that means that my final answer is positive 8 125ths, or 8 125ths. Now, something about negatives and fractions that I want to note. So this is just a side note, because you may have been thinking or wondering, well, how do I know where a negative goes? So I'm going to use an example. Let's use the example of -3/4. Okay, so again, this is how do you know where a negative goes? Keep in mind that fractions are division. That means that -3/4 is the same as -3/4, because a negative divided by a positive is negative. Well, if the whole thing is negative, that's what this is showing you. Well, that also equals 3 over negative 4, because a positive divided by a negative is also negative. So you can rewrite a negative fraction in all 3 of these ways. The last one we don't tend to see very often, so I usually rewrite stuff into either of these formats. That last one is not incorrect, but you may feel like it's kind of confusing because we don't see it very often. So just wanted to make that note. Okay, so for the next ones here, we are moving into order of operations. So I'm going to go ahead and stop this video and create another one that is also section 4.6, but it will be section 4.6 fractions with order of operations. So this will also provide a good opportunity for a review of GEMDOS.